Tuesday evening, I tried to, I think unsuccessfully, hope I'm wrong, explain to you guys what it is that you're trying to do when they get you to determine a general solution, so that you're not just working in the dark, you're working with some understanding of what it is that you are doing. I think some of us were quite confused, and I think for others, hopefully a light bulb went off. It's one of those things, I think, when someone explains to you, when they teach it to you the first time, that either you're like, wow, okay, I get this, it makes sense, it all ties together now, or it's one of those things where you're like, I don't know about that, it's not making any sense to me. So please, if you have got any questions, or you want me to sort of re-explain what it was I was trying to do the other night, that's fine. I'm more than happy to do that. Um, General solutions are so extensive. There's so much on it. I mean, they can give us questions where they can bring in our compound angle formula. They can bring in our double angle formula. They get us to factorize. There's all sorts of things. So there really are lots and lots of examples that I need to do with you in order to try and, hello Nolwazi, show you everything that could potentially be asked. All right, so let's start here with this particular question. All right, so they just want us to do a general solution. So that means that we need to find our value for theta plus k times 360, or k times 180, or whatever the case is. I think this is going to be a cos one, so it'll be k times 360. We don't actually have to solve for any angles in this particular case. All right, so if we look at the left-hand side of our equation, right, I'm just going to make this a little bit bigger. What does it look like? What can I do with the left-hand side of the equation? What do you see on your formula sheet that you recognize that you can use, Matrix? So this is cos 4 theta cos 40 plus sine 4 theta sine 40. What do you see? Compound angles. Absolutely, Mamelo. Quite right. They're compound angles. So how should I write cos 4 theta cos 40 plus sine 4 theta sine 40 if I want to use the reversal of the expansion? How would I write it? There we go, Mamelo. Lovely. Okay, good job. All right, well done. So Mamelo spotted that straight away and said, okay, what we are looking at is this: cos A cos B plus sine A sine B. So we are going to go backwards and we are going to do this with it. So cos A minus B. All right, well done, Mamelo. Good spot. That's exactly what I was hoping you would see. This one didn't even need any manipulating. I'm just going to make that smaller and I'm going to pop it out the way. And as Mamelo told us, we are now going to write this as cos 4 theta minus 40 degrees is equal to -1. All right, so once we've got to the stage where either the cos, the sine, the tan of an angle is equal to a ratio, what is the next thing that we need to do when we are working with general solutions? What's our next step, Matrix? What do we have to get? An RA. Good. We need an RA or a PAA. That's fine. A reference angle. Okay, and how am I going to get, what is my reference angle in this case? Can anybody tell me? What should my reference angle be? What's my reference angle? Mm-hmm. Okay, so in Nhlanhla, it can't be 180. Okay, your reference angle always has to be acute. Okay, your RA always has to be acute. And now the problem is that you were using your negative. Okay, remember that's why my school where I am, we call it a PAA rather than an RA. Okay, to remind you that it needs to be a positive acute angle. Okay, so your RA or your PAA has to be a positive acute angle. In this case, you are quite right, guys. It is 0 degrees. Okay, now that we have our PAA, we are looking at our ratio, which is -1, and we are thinking about the cast diagram. And we are saying to ourselves, in which two quadrants is cos theta negative? Cos theta is negative in quadrants 2 and 3. Okay, so it's because of this negative over here that we are working in quadrants 2 and 3. You don't need to write this. I'm just writing this for you so that you know where it comes from. You don't have to write quadrant 2, but in quadrant 2, we would say our angle is 4 theta minus 40 is equal to 180 minus our PAA plus K times 360. K is an element of the integers. And remember, K represents when we make a turn around the Cartesian plane. Okay, 1 multiple of 360. Okay, now let's take the 40 over to the other side. So this is going to give us 220 plus K times 360. K is an element of the integers. And the last thing that we need to do is divide through by 4 every term, okay, including the K times 360. So we are going to end up with theta is equal to 55 plus K times 90. K is an element of the integers. Okay, now in this particular example, we are also supposed to be doing a solution in quadrant 3. Why am I not going to worry about doing a solution in quadrant 3 in this particular example? What happens in quadrant 3? Can anybody tell me what happens in quadrant 3 in this particular example? What is my reduction formula for quadrant 3? What's my reduction formula for quadrant 3, Matrix? Exactly, 180 plus. So Lebogang, good. Boitumelo, good. Well done, it's 180 plus. So if I have 180 minus 0 in quadrant 2, and I have 180 plus 0 in quadrant 3, is my general solution going to be different in quadrant 3 than it is in quadrant 2? No, exactly, Lorraine. Exactly, Lebogang. The answer's not going to change in this case. Okay. Right. But it's just in this case only because our reference angle or our PAA was 0 and we were working where cos theta was negative. All right. So I'm not going to go through the whole process all over again just to get the same answer. Okay. So in other words, I'll just write it here for you very quickly. 4 theta minus 40 would be equal to 180 plus 0 plus k times 360. Can you see now? You're not going to get a different answer because whether you add 0 or take 0 away, it's not going to change anything. Okay, so in this particular example, there is no need for us to do a solution in quadrant 3. Okay, so we would simply have stopped here, and that would be our final answer. Okay, are we all good to go? Is everybody happy? Are there any questions? All good. Okay, all right, lovely. Thank you, Mamelo. Thank you, Lebogang. Cool. Okay, so let's go on and go and have a look at some of the other kinds of questions they expect us to be able to do. And here, let's drag this guy with us. Come our factorizing and our double angles and our, well, we've done one with compound angles. Our factorizing and our double angles come out in these ones. Okay, all right. So let's go and have a look at question A. All right. They want us again just to find general solutions. They're not asking us to solve for any angles. And they give us sine 2 theta plus 2 sine theta equals 0. So what matrix are we going to do with the sine 2 theta? How are we going to write that? What are we doing with this guy? Sine 2 alpha. Must I make it bigger? What are we doing with sine 2 alpha matrix? Okay, expand the double angle. Good. Well done, everybody. So we're going to expand our double angle. And we are going to write sine 2 alpha as 2 sine alpha cos alpha plus 2 sine alpha equals 0. Okay, lovely. There we go. Okay, so we've expanded it. Now what are we going to do? What's the next step, do you think? That's it, and factorize. What are you going to take out? Or how are you going to factorize? Yes. Yamkela, good. Lisa Kanya, good. How are you going to factorize it? What are your factors going to be? Okay, so Nhlanhla says take out 2 sine alpha. All right, I'll take out 2 sine alpha. And that means that in brackets, good, yes, lovely, we would be left with cos alpha plus 1. That's it. Lovely, Amahle. Good, 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 good. Okay. So now that we factorized, we can say either 2 sine alpha equals 0. So either 2 sine alpha equals 0 or cos alpha plus 1 is 0. So either sine alpha is equal to 0 or cos alpha is equal to negative 1. Okay, now that we are in this situation, Okay, we have to do a general solution for where sine alpha equals 0, and we have to do a general solution for where cos alpha equals -1. Okay, can I let you guys do that by yourselves, and then you share your answers with us? So you guys do this, and then when you're done, you're going to say done on the chat, and then you can either DM myself or Yolanda with your solutions. Okay.
Let's do this, Matric. Let's do this. We can. Let's go.
No, 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 Lisa, Kanya, I don't need you to do B. Are you finished? Have you done A? We are going to do B together, but I just wanted you to do A first and share your answers with me, DM them to me, and then when I know that you're okay, we can go on and do the others.
Yeah. And also just let us know when you are done or something
Yeah.
like this. We can see.
Yeah. Shem, I suppose it is a bit difficult, but yeah, tell us when you're done, and then we can go on from there. Okay, Intlantla, that's great. Don't know how easy it is. I know it's a bit difficult with the K's and the alphas and the all sorts of things in there. Intlantla, see if you can DM me your answers. Are we okay, guys? Are we still working? Are we all right? Are we managing? We're still busy or we're struggling? Struggling, struggling. Okay. All right. That's fine. That's fine. That's fine. That's fine. No problem. No problem. That's why I don't want to leave you. Okay. All right. No problem. Okay. So this is what we would have to do in this case. I know these are difficult. It's okay. Yes, Nhlanhla, you're on the right track, Nhlanhla. That's good. Okay, I'm going to show you now, Nhlanhla. Yes, that's right. Okay, if you are struggling, I understand 100%. These are particularly difficult questions. Okay, so don't feel bad at all. Okay, so your ratio is 0. So let's work first with where sine theta equals 0. Okay. So your ratio is 0. So when you find your PAA, you should have also worked out that it was 0 degrees. Okay, did you get that? So for sine theta equals 0, did you get your PAA is 0 degrees? Yes, good. So what we do, matrix, is that when our ratio is 0, right, we consider, in trig, we consider this 0 over here as positive. So in other words, when we're now looking at our cast diagram, we would consider this 0, we would say that that was positive. So in which two quadrants is sine theta positive? Quadrant 1 and quadrant 2. So that's where we have to do a solution. So in quadrant 1, we would say our angle in this case is just alpha. Okay, there's nothing else that needs to be done to it. It's just alpha is equal to our PAA, which is 0 degrees, plus K times 360. K is an element of the integers. Okay, and if you want to, what you could do is you can just write this as alpha equals K times 360. Because obviously if you add 0 to something, it doesn't make any difference. So that is what would happen in quadrant number 1. Or if we consider what happens in quadrant number 2, our angle is alpha. It would be equal to 180 minus our PAA, which is 0 degrees, plus K times 360. K is an element of the integers. Okay, so here alpha would be equal to 180 plus K times 360. K is an element of the integers. And there are your two general solutions for sine alpha. Okay, so how did we do with that one? Was that bit okay? Yamkela, because that is your reduction formula for quadrant number 2, 180 minus. Okay, so if we are working in quadrant 1, we're working with our PAA. If we're working in quadrant 2, we use the reduction formula 180 minus our PAA. If we work in quadrant 3, we use the reduction formula 180 plus our PAA. And if we're working in quadrant 4, then it would be 360 minus our PAA. Does that make sense? So that one was okay. All right. And then cos alpha equals -1. Well, here again, if you worked out what your PAA was, again, it ended up being 0 degrees. It's actually exactly the same as this one that we've just done over here. Okay, remember we ended up with cos of an angle equal to -1. So our PAA was 0 degrees. It's exactly the same thing. Okay. So here, our angle is alpha. So before I say that, we are considering where cos alpha is negative. So again, our cast diagram, in which two quadrants is cos alpha negative? In quadrants 2 and 3. So those are the quadrants that we need to work in. Okay, in quadrant 2, we're going to end up with our angle alpha being equal to 180 minus 0 degrees plus k times 360. So that means that alpha will be equal to 180 plus k times 360. Okay, now you can see here that this solution over here is identical to that solution over there. All right, now that's just coincidence in the question, but we don't need to keep repeating ourselves if we got the same answer. Okay, so if we are solving, for example, let's say we solve for x squared minus 6x plus 9 equals 0. And then when we factorize, we end up with this. So we don't have to say x equals 3 or x equals 3. We can just say x equals 3. We don't have to repeat our solutions. Okay, so it's the same story here. When we get a solution and when we get another solution that's the same, we don't have to keep on repeating ourselves. What you would find, again, like the previous question, over here, quadrant 3 will give us the same solution as quadrant 2, because in quadrant 3, we would be saying alpha equals 180 plus 0 degrees plus k times 360. So can you see quadrant 3 gives us the same solution as quadrant 2, which gives us the same solution as quadrant 2 for when sine alpha was equal to 0. Okay, so same story here. Sorry, that shouldn't be it. Equals alpha would be equal to 180 plus k times 360. Okay, so you actually wouldn't even have to do this second quadrant 3. Yes, Amatle, I see your hand is up.
Good evening, ma'am.
Good evening, Amatle. How are you?
I'm writing yourself. Why
I'm
isn't our
fine.
reference angle for the cos alpha is equal to -1? Why is our reference angle not 180?
Okay. Your reference angle is supposed to be an acute angle. It's supposed to be an angle in the first quadrant.
Okay.
Okay, so all your reference angles are always acute angles in the first quadrant because we always try and work with an angle in the first quadrant. Okay, as our starting
okay.
point. Okay, and then based on that, we then can say, okay, if k was equal to 1 or k was equal to 2 or k was equal to 3, we could then cycle forwards or cycle backwards depending on what the question wanted. But your reference angle is always supposed to be an acute angle in the first quadrant.
Oh, okay. Thank you, ma'am.
Okay.
Was I not supposed to put the -1 when I said shift
No,
cos?
no. So whenever
Okay.
this is a lovely talking point, Amatle. Everybody else, thank you for bringing this up. Everybody else, listen very carefully. When you have got a negative, let's say you've done a whole bunch of working, and now you end up with sine A equals -2/3. You do not use the negative. Oh gosh, the green on the green really wasn't great. You do not use the negative to find your PAA. You'll use your negative to determine which quadrants you work in. So here, when you are calculating your PAA, you ignore the negative. So on your calculator, for example, you would go shift sign and you would put in 2/3, not -2/3. Okay, and you would get a PAA, a positive acute angle of 41,81 degrees. Okay, so you ignore the negative. The negative is there to tell you which quadrants to work in. So now when you come along and you want to do your general solutions, looking at your class diagram, you are saying to yourself, my ratio is negative. In which two quadrants is sine A negative? In quadrants 3 and 4. Amahle, does that make more sense? Okay, so in quadrant 3, if we were solving for angle A, if we had to do a general solution, we would say that A is equal to 180 plus our PAA. Plus, let's just move over a little bit here. K times 360. K is an element of the integers. Okay. Which would give us 221,81 plus K times 360. That would be for quadrant 3. Okay. Or you would have to work in quadrant 4. Okay, where you would say your angle A is equal to 360 minus 41,81 plus K times 360. Okay, matrix. So I've just made this up based on Amatle's question. I'm hoping this makes sense to all of you now. Okay, so if you have got a negative ratio, you do not use the negative to calculate the PAA. You ignore the negative and you calculate your PAA so that it is a positive acute angle. Okay, it has to be less than 90. And then if you are working with sine A and it's negative, you will be working in quadrants 3 and 4. If you were working with cos A and that was equal to a negative number, then you would be working in quadrants 2 and 3. If you were working with tan A and that was negative, then you would be working in quadrants 2 and 4. Okay, can I get a thumbs up? Is this making sense to everybody? If you want me to explain it again, that's no problem at all. How are we feeling now? Okay, all right, good. Are you guys learning something from these lessons here with me? Am I helping you guys? Is this making sense to you? Are you sure this is helping? So there's things that you heard at school that maybe didn't make sense to you, and now when you sit and you listen to me and we're talking about it, it's oh good, oh good,
Nice, my
oh
people.
good. Okay. No, that's what I want. That's what I want. I want these discussions that we have here to be meaningful to you and that you understand things that perhaps in class went over your head.
Yeah.
Okay. All right. Lovely. Good. Anyway, stop me at any time if you want to ask me any questions. Yes, let's have a look at question B now. Let's have a look at question B. Okay. So that's this one over here. Again, they've asked us to do a general solution. Okay, so let's go down here. So 2 sine squared alpha hang on, plus sine alpha equals 3. Okay, so we're going to do a general solution here as well. What I want you to see with this particular question is that this is a trinomial. If I said so in other words, if you could imagine here that sine alpha was equal to the variable y, you'd end up with 2y squared plus y minus 3 equals 0 when you got it into standard form. So it's exactly the same thing here, only now we're working with trig. Okay, so we're going to bring the 3 over, we're going to make it equal to 0, and then we're going to factorize. So here on the side, I'm going to write 2y squared plus y minus 3 equals 0, and we're going to use that to help us to factorize. Okay, so let's get it into standard form first of all. We've got 2 sine squared alpha plus sine alpha minus 3 equals 0. So now we've got to factorize. When we factorize trinomials, we know that we need 2 brackets. Remember, in the line with your factors, don't leave off the equals 0. Okay, because they mark us on factors the whole way through in caps. If we were factorizing this on the right, we would put 2y in the front of the first bracket. We'd put y in the front of the second bracket. Okay, so 2 is a prime number and 3 is a prime number. So they've been kind to us now. Where do we put, what am I going to put with the 2y and what am I going to put with the y? Okay, so Lorraine, 2 sine theta, and then sine theta. Mamelo says 2y plus 3. Okay, and then would this be minus 1, Mamelo? Is that what you would do? You could, Yamkela, you could use the quadratic formula. You could. Lisa Kanya also says 2y plus 3. All right, you could use the quadratic formula if you needed to. Let's just check. So 2y squared minus 2y plus 3y. Lovely, beautiful. Okay, so this is some gorgeous factorizing right here, guys. We're going to do exactly the same thing on this side with our 2 sine theta. So we'd have 2 sine, alpha plus 3. Here we would have sine alpha minus 1. And now that we have factorized, let's just move this guy down and out the way. Okay, so Lisa Kanye, if you wanted to do the quadratic formula, all right, you would have had to say something like this. Okay, so y would be equal to negative b, so that would be negative 1 plus or minus b squared, so that would be 1 squared minus 4, a is equal to 2, and c is equal to negative 3, all over 2a would be equal to 2. So it would be like that. Okay, or you've got sine alpha here. Okay, so either you can give it the name of a letter. The only thing that you can't do is call it the letter that you're solving for. So like if you had x over here, you can't work with x over there as well. So just choose a different letter. Okay, and then you would have 2 different values or 2 different solutions for sine alpha. Sine alpha would be equal to something, or sine alpha would be equal to, not 1, whatever it is. Okay, well, it is 1, but I mean, anyway, never mind. We'll fill that in now. Okay, so either sine alpha is equal to negative 3 over 2, or sine alpha is equal to 1. So either sine alpha would be -3/2 or sine alpha would be equal to 1. Okay. Now, when it comes to this, sine alpha equals -3/2. What happens here, matrix? Can sine alpha be equal to -3/2? Okay, no, it can't. Why? Why can't it? Why would we say here that there is no solution? Why is this happening? Why are we getting no solution possible here? Agreed, no solution. But why, matrix? Why is there no solution? Good, Yamkela, that's good. Well done. You're getting the right answers. Math error. But why, Mamela? Why is there a math error? Am I being mean here? I'm asking you difficult questions. Why does it say math error? Yes, it does. It does say math error. And again, it goes back to our understanding of the graphs matrix. If we understand the graphs, then we understand why there is no possible solution here. No, not because the angle is less than 90. Not at all. Let's think about our sine graph that I was drawing or discussing with you the other night. Okay, so remember what our sine graph looks like. If we are talking about sine alpha or y equals sine alpha, which is what we've got in this case, our graph does that, doesn't it? It has a maximum of 1. It has a minimum of -1. Okay, so that is why sine alpha cannot be equal to -3/2 because that's -1.5. Okay, that's why there's a math error. Okay, this is why I want you to understand the graph so much. Okay, Lebogang? Okay, so when you were talking about sine alpha and cos alpha, and you were doing general solutions, okay, there is a restriction on what your ratio can be. Your ratio can only be between 1 and -1. It can't be any bigger and it can't be any smaller for sine alpha or cos alpha. All right, otherwise there's going to be no solution. So again, if you got an answer and you said cos alpha is equal to 2, and you go shift cos and you put in the 2, your calculator says math error. Okay, so remember that for sine alpha and cos alpha or sine theta and cos theta, there is a restriction on your ratio. Your ratio, whatever it is, it can be greater than or equal to -1 or smaller than or equal to 1. Okay, but it cannot be any smaller than -1 or any bigger than 1, and there would be no solution. Okay, for tan theta, it doesn't matter. Okay, it can be anything. There's no restriction. There's no maximum and there's no minimum. All right, so that's why we end up here with no solution as our answer. Okay, are we feeling good about that? Everybody happy? Thumbs up. Good. Good stuff. All right, and again now with sine alpha equal to 1, we need to find our PAA or our RA. Okay, so when we find our PAA, it's 90. Our PAA is 90. Our ratio is positive 1. So again, in our CAST diagram, we've got to do a solution where sine alpha is positive, either quadrant 1 or quadrant 2. Okay, so in quadrant 1, our angle alpha is equal to our PAA plus K times 360. K is an element of the integers. Or in quadrant 2, alpha would be equal to 180 minus our PAA plus K times 360. K is an element of the integers. So interestingly enough, we get the same solution or general solution for both quadrants here. So we wouldn't actually have to repeat ourselves the second time, but there we go. All right, so this really is our solution in this case. Okay. Everybody happy with that? That's fine. Yes, Nhlanhla, you can. Okay, so Lisa Kanya, why is our RA 90 degrees? Because when you find your PAA, you're going to go shift, sign, and then you're going to put in the 1, and then it gives you 90. Okay, and again, it goes back to our graph. Okay, so we're still in quadrant 1, essentially at 90. There's 90. Okay, so it would be equal to 1. Okay, so remember your ratio is allowed to be 1. It's allowed to be -1, but it can't be any bigger than 1 and it can't be any smaller than -1. Okay. Lisa Kanya, does that make sense? It's a pleasure, Amahle. You see, the thing is, Amahle, when you are taught general solutions, yes, of course you can, Mamelo. You can take as many screenshots as you like. When you are taught general solutions, the idea is that whoever's teaching it to you must explain the graphs together with the general solution at the same time so that you can tie all of this stuff together. Right, and that's what I was trying to do the other night with you guys when we were talking about the graph, was to tie, your perspectives on all of these different things together. But don't worry, we're going to have lots more lessons like this before the end of the year. This is definitely something that I want to come back to, because yeah, it generally always gets asked. Okay. All right, how much time have we got? 10 minutes. Okay, so let's go back and just have a look at the last, actually, hang on a second. Where did I saw one? Okay. I want to do one more with you. Okay. And I'm going to do this question over here, D. I want to do this one with you as an example. Okay, so we've got cos 2 theta equals sine theta plus 1. Now, we all know that we've got a cosine double angle. Let me just go and fetch our thing. There it is. How do we know how to write our cosine double angle? How are we going to write cos 2 theta? We have 3 options. Which option are we picking? Good. Well done, Mamelo. Well done, Amatle. Okay, very nice. So when you see cos 2 theta with cos theta, then choose the second option. If you see cos 2 theta with sine theta, choose the last option, 1 minus 2 sine squared theta, and make yourselves a trinomial. Okay, so we're going to make that guy small. We're going to write cos 2 theta as 1 minus 2 sine squared theta equals sine theta plus 1. And we're going to get it all into one side. So I'm going to take over my 2 sine squared theta plus my sine theta. And then here I would need to minus 1. So here I would minus 1. So I would just end up with that. And now I've got to factorize. Okay, so look for compound angles. Look for double angles. Use compound angle formulae, use double angle formulae. After you've done that and you've substituted them in, then look at, get it into standard form, and then start thinking about factorizing. Okay, that's the general idea every single time. Okay, so either use compound angle formulae or double angle formulae. Substitute, get it into standard form so that it's equal to 0, and then start thinking about factorizing. Amahle, go for it.
Ma'am, when we factorize this one, since it's no longer a trinomial, it's now a binomial, do we just do dots?
Not dots. Dots is difference of two squares. We're
Oh,
just going to
that's
do
fine.
highest common. It's okay. It's okay. Don't ever say sorry. You're going to do highest common factor. Okay, so it's either going to be difference of two squares or a trinomial or take out a highest common factor. Okay.
Thank you, ma'am.
All right, no problem. That's it. So Nhlanhla says sine theta. Good. Okay, go for it, Nhlanhla. Carry on working. See if you can get this finished. And we're going to take out sine theta. So that's going to leave us with 2 plus. Oh, sorry, I'm talking nonsense. 2 sine theta. 2 sine theta plus 1. Lovely. So again, you're going to have sine theta equals 0, or sine theta will be equal to negative 1 over 2. Okay. That's it. Okay, so unfortunately, we don't have much time. Let's finish this off together. Remember, we said that when sine theta was equal to 0, we would treat 0 like it was positive. So in terms of our cast diagram, we are going to do solutions in quadrants 1 and 2. Our PAA is 0 degrees. Okay, now again, that's because of the graph. If you go back up here and have a look, there is 0 degrees, isn't it? There's 0 degrees. This is 0 degrees here. And on your graph sine theta, it's equal to 0. Okay. So that's why I always keep going back to the graphs every time. So in quadrant 1, our angle theta would be equal to 0 plus k times 360. K is an element of the integers. Or in quadrant 2, we would end up with theta equals 180 minus 0 degrees. So that would be 180 plus k times 360. K is an element of the integer. So that one was quite easy. Now, for sine theta equals minus 1/2. Remember, when we calculate our PAA, we do not use the negative. The negative is there to tell us which quadrants to work in. Okay. Yes, Lebogang, quite right. Our PAA or RA is 30 degrees. Cast diagram. Now we've got to work where sine theta is negative. Quadrants 3 or 4. So in quadrant 3, we will say our angle theta is equal to 180 plus our PAA plus K times 360. K is an element of the integers. So theta would be equal to 210. Okay, or quadrant 4, theta would be equal to 360 minus our PAA. Okay, so theta would be 330. Amatle, do you want to ask a question?
Yes, ma'am. For the equation, because I had it as before I factorized, I had it as 2 sine squared theta minus sine theta, and then I factorized sine theta out, and then I got 2 sine minus 1 because I took the sine at the beginning, because I took the sine from the right and I took it to the left, and the 1 as well.
Okay, so if you ended up, you shouldn't have got a different answer. Something must have just been transposed incorrectly. But